Hey, Charlie Pyatt here. Well, we made it to the final assembly steps of the AR/VR headset. I actually started this project almost a year ago and have been messing around with these concepts for even longer, so it's a big deal for me to be wrapping this project up. And a bunch has happened in the augmented reality and virtual reality space since I started with this one. Oculus has announced their Quest 3 and Apple has shown their Vision headsets. Both of these designs feature augmented reality overlays from forward-facing cameras displayed in VR. It's all really exciting to see how much activity is in this space and how quickly the landscape is changing. Since this is the final episode in this series, I wanted to spend some time looking back on the work it took to get here. With that in mind, I thought it would be a good idea to do a quick summary of the episodes leading up to this one. So let's get going one last time. The end goal of this project was to make a headset that would let me create and experiment with virtual augmented reality interfaces. I started off by identifying the basic off-the-shelf hardware I could combine together to make this happen in a custom headset. My headset would use an Oculus Quest 2 for the displays with forward-facing cameras and a hand-tracking unit positioned underneath those stereo cameras. I didn't know it at the time, but this seems to be the same strategy that is being used with the Oculus 3 and the Apple Vision. The other unique aspect of this headset is the custom facial interface. This custom lattice design is generated from a software system I put together. The software pipeline basically takes in a 3D face scan from an iPhone's Face ID and outputs a custom mask that perfectly fits a user's head. To kick off the creative process, I started off by sketch rendering a concept of what the headset might actually look like. This was done in Photoshop and just intended to get some basic ideas of form, possible materials, and color exploration. I ended up going with dark gray and pink highlights for the main color direction. I also wanted to use some machined carbon fiber sheet stock on my 3D printed parts for a really nice material change. With the basic design concept out of the way, it was time to move on to the hardware side of things. With that, I switched over to tearing down my Oculus Quest 2. This hardware would drive the overall form of the rest of the design. I removed the Quest from its enclosure and started modeling the internals in Fusion 360. That way I could build up my custom design around the Quest internals. At this point I realized I wanted to still use the Quest as a standalone device, which means I didn't want to obstruct the tracking cameras at the corners of the hardware. This means I had to fit the forward-facing cameras and hand tracking module inside the view cones of the Oculus. This ended up driving the final form of the design and making the whole headset have a really unique and interesting style. I did a quick animation of the design in Blender using the color and material choices from the first episode. With the basic design out of the way, I wanted to see how the proportions would look in real life, so I did a quick 1:1 cardboard mock-up of the design. To get this done, I generated a full-scale drawing set in Fusion and printed them out on my home laser printer. The prints were cut out and spray mounted to cardboard, then I hot glued the final together for the rough model. This gave me a vague idea of the size of my design compared to the Oculus enclosure. This step really helps make sure the proportions of the design aren't getting too far out of hand for the final construction and a sense of the real-life size of everything. Now that I knew my overall form would be okay, I got into the exact process I would be using to fabricate my parts. In this episode, I went into the differences between injection molding and 3D printing. I also went into a more detailed breakdown of the various types of 3D printing, as well as the pros and cons of these different 3D printing processes. Because my custom facial interface design was going to use 3D scanning technology, I also went over the basic types of 3D scanning as well. This covered an overview of how this technology works and the pros and cons of the different 3D scanning methods. I wrapped this one up by creating a 3D scan of my face that I would use as an input for the custom face gasket design. I got the scan from the Face ID feature available on any modern iPhone. With the 3D scan of my face created, I started going into building the software pipeline that would generate my custom face mask on the headset. This software would take in any 3D scan of a face and generate a custom fit part with an adaptive lattice design. Went over the basic steps in generating the custom parts as well as the features found in the final output. I'm a big believer that automated mass personalized products have a big future in the industrial design field, so this aspect of the design was something I really wanted to explore. I think you can add a lot of value to a consumer product that is custom generated for each person through software. The ability to do this cost effectively is a very new thing, and I think has only been possible for the last several years or so. In any case, I was really happy to develop out the software solution for this design that would take 3D scan data and generate a custom mask. At the end, I did some new animations with the custom face mask integration into my existing headset design. This helped get a clear picture of how the custom face part would integrate with the rest of the hardware enclosure. To wrap up this episode, I did a full-scale test print in clear resin to make sure the overall fit of the custom mask was correct. It ended up fitting great. It was an amazing feeling to get the custom mask out of the generation software and into the real world. With the custom face gasket complete, I still had a lot of hardware integration and detail work in the CAD model to do. This involved pulling in the 3D models of all the screws and nuts that would hold the headset together. I also still had to finish some basic design work in the headphones and mechanical design of the rear tightening system. This detail step really takes up the bulk of the design process and takes the 3D model from being a visual concept to a complete buildable product. By the end of this, I had a mostly complete final design of the headset. I took the 3D model into Blender again to do some animations of the current design and check the range of motion and clearances of some of the parts. I also did some exploded views to get a better idea of how the headset would be assembled. In episode 7, I output test prints of all my parts to see what the fit was like in the real world. These are all sacrificial printed parts, just to check what adjustments I needed to make for the final set of 3D prints. These parts were done in a clear resin so I could see into the body of the enclosure and more easily tell where things were not fitting or where clearance issues were happening. I marked up my parts with a Sharpie and then translated those adjustment notes back into Fusion 360 to update the design. Some of these parts took multiple cycles of updates and test printing to get dialed into their finished form, but fortunately it was a pretty painless process to get everything fit together. At this point I could finally put the headset on for the first time and get a feeling of what the final design would actually be like. It was a pretty great moment in the whole process of the project. You could finally start seeing everything come together. With all the adjustments done, I could get on with printing my final parts. The parts were split up based on their manufacturing process. I was having an outside fabrication house do those flat carbon fiber elements, so I put together the 2D vector work for those and sent them off to be cut. The rest of the components were being 3D printed at home in a high-resolution gray resin. I had to generate a bill of materials and do a decent amount of tracking to make sure I didn't miss any parts for this phase. But by the end of it, I had all the parts in hand, ready for dry fitting and finishing. With my parts fabricated and in stock, I did my finishing and painting on the components. I used rattle can spray paint on these and was a little worried about the finish quality, but the results came out surprisingly nice. The custom gasket was the last part that still needed to be done, so I printed that out in a flexible elastomeric resin. This resin only came in clear, which would have been a problem for light leakage when the headset was on, so I decided to do an experimental dye process on these finished parts. I switched things up even more and did a fade move on the front custom headset part and was really happy with how it came out. The custom face gasket and back pad were my last two parts that needed to be fabricated and finished on this project. So this brings us to where we are now. All the parts are done and coming together in one final assembly. Generally, I need to assemble the parts from the inside out, starting with the main enclosure. So the first parts I attached are the left and right pivot arms. My headphones will mount to these as well as my side strap system. These can pivot up and down a fixed amount to allow the pitch of the headset to fit on my face more comfortably. These pivots also have a little center notch that allows me to feed my headphone cabling through to the inside of the enclosure. I added some gear lubricant between the pivot and the enclosure wall to make the action as smooth as possible. Finally, put a dab of Loctite on each of those screws to secure them in place. In the end, the pivoting motion felt great. It has some good heft to it like a high-quality product should. Once again, I'm so glad I went with these machined carbon fiber parts for the high stress and infill components. If I had made these arms out of 3D printed parts, I would have had to make them pretty thick to keep them from deflecting. With the carbon fiber parts, I can keep the sides of the enclosure nice and slim. The final bonus these parts give me is tighter tolerances. Even high-resolution 3D printed resin parts tend to shift dimensionally a little bit. This makes mechanical elements that need to fit together a little finicky to dial in when 3D printed parts are connected together. Because the carbon fiber parts are pretty much spot on, I don't have to mess around with my tolerances quite as much. It's just a really nice method for building products using 3D printing. Up next is the headphone assembly. If you remember back to episode 6, I'm using drivers off a pair of donor headphones. Nothing too fancy, but they should get the job done. I wired the drivers in place and left plenty of cable to feed into the enclosure. I'll splice these onto the old Oculus 2 PCB speaker plugs in a later step. These speakers just press fit into the enclosure and are sandwiched between layers of 3D printed parts and carbon fiber sheet stock. These are an open ear design, and I really like the way they came together. You can see the driver through the outside grill, and the speaker has this really funky pink inside detail. Such a fun look with the carbon fiber detailing. I seated the black aluminum standoffs onto the pivot using a quick clamp and fed my long machine screws through the standoffs so I could screw them into the speaker enclosures. These extensions allow the headphones to pivot or roll off their normal axis to give a better fit on my head. You might also notice that I removed material from the old 3D printed pivot arms. This was to let those headphones flex a little bit more and not clamp down as hard when I'm wearing them. These parts then get connected to that carbon fiber extension arm I attached to the headset enclosure in the previous step. Final thing to do on these is to slip the muffs over the carbon fiber edge of the headphone assembly. These are actually a little tighter than I expected, but I stretched them out and they worked out okay in the end. At this point, these are good to go and be attached to the main enclosure. Again, I really love the way these came out. Might have to adapt this design for some normal use standalone headphones in another side project. Back on the main enclosure, I'm attaching the connectors for the rear tightening assembly. The paracord coming off the back tightening unit will loop through these to allow me to tighten the sides of the headset securely on my head. The headphone assembly also locks into the center hole of these parts when the headphones are folded in to secure them into place when not in use. Now it's time to attach the headphones to the main enclosure. The headphone assembly actually attaches to slots in the side of the enclosure arm there. This lets the whole assembly slide forward and backward as well as pivot at 2 points for the best possible fit on the ear. In the final step of the main enclosure assembly, I'm pulling the cable from the headphones through the enclosure and will solder them onto the board connectors on the Oculus. After this, I will pack the Oculus into the new enclosure and fix it in place with a couple plastic screws. The next subcomponent to get together is the front faceplate and bezel. The section is removable from the main enclosure and will hold my forward-facing camera and hand tracking unit. The front faceplate takes in these 3D printed surrounds. These parts were made to let me make minor adjustments to the position of the cameras if my reference CAD turned out to be off. I ended up not having to make any tweaks to these, but the prints do a nice job of covering the edge of the carbon fiber and making the design look more complete. These are just fixed in place with a couple of countersunk screws. The alignment of these came out really nice in the end. My guesswork tolerances really worked out somehow. The smaller pink parts are for the hand tracking module. I really like the little design detail of how these wrap over the carbon fiber sheet and 3D printed bezel. The front faceplate then drops into the front bezel. The bezel will also hold the frame that holds the forward-facing camera and tracking bar. The edge countersunk screws secure the plate in place, and again, everything's coming out super smooth. The last big step in the assembly process is finishing the back tensioning unit. This works by tightening paracord straps that run over the top and sides of my head, letting me adjust how tight the unit is on my face and how high it is on my head. The way this operates is by using worm gears to pull in or release the paracord around a couple spools in the rear enclosure. There's one gear set for the top cord tension and one for the side tension, and these stack on top of each other. For the assembly, I basically tie a length of paracord into each main gear. I left the paracord oversized so I can just trim it down once I have it connected to the front display unit. I applied some gear grease to each of the worm gears, which helped a lot with the action of tightening the paracord. Both gears are 3D printed and were much more prone to binding before I got the lubricant on there. It's a relief this pretty much solved the problem. So right, from here I just load the gear stack into my rear spindle and work the grease into the threads by loosening and tightening the gear a bit. It's kind of tough to explain, but there's a sleeve that suspends the outer gear off the inner one. This keeps the two main gear spools from rubbing together and binding up. With everything installed, I can just pop my carbon fiber backplate on. The outer pink 3D printed part captures everything in place and is held down by a few countersunk machine screws. The final step is to attach the rear pad to the enclosure. This pad is made of a softer material, so I can just flex it into place. I was going to glue it down, but after I force fit it onto the enclosure, it was pretty well secured, so I'm just going to leave it as is for now. With that, I can tie this unit into the front display enclosure, and that finishes the assembly. With the main components put together, I really just needed to finish packing the hardware in the enclosure at this point. I also need to keep in mind how my cable management was going to come together with everything. The rear enclosure will have a single USB cable coming off it, while the front will have two cables coming out of the current layout. With the Oculus 2 loaded in the main housing, I still have to attach the external port and button covers. These are designed to be attached from the outside of the new enclosure, so I basically just pop the FlexPrint circuit connected component out of the hole in the housing, and then fix the matching cover port back in place. With that done, I attached the Z Mini forward-facing camera and the IR170 hand tracking module to their internal mounting frame and screw them into the front bezel assembly. Both parts of the front display unit are all now finished up. You can see all the cameras are lined up great with that front cover. I also added a USB angle connector on the side there to redirect the cable coming off the IR170 hand tracker. The custom face gasket is seated in place as well, so all that's left is to clip that front tracking hardware onto the main housing. Custom facial interface is made of a soft material and basically just fits over a ridge on the hard enclosure. It's pretty easy to get on and off and also holds in place really well too. The front bezel part actually has two screws that come in from the back of it to secure it in place for final assembly. You can see the front bezel here just resting against the front of the main enclosure for final fit checks. And at this point, everything's finally assembled. The front bezel is screwed in place, and the paracord tightening back unit is all tied into the front assembly. It's so amazing to finally see this all out in real life after all the design work, planning, and assembly. I added a couple of parts that tie down that paracord and make it so I can pop the rear tightening unit off without disassembling everything. Otherwise, the design is sticking pretty close to how I envisioned it. I can also push that rear unit into the headset and compact this whole thing down to a pretty small package for storage. The headphones pop right into their closed position really well too. It's so nice seeing this all together. It's nuts to finally have this on my head. Such a weird feeling. I've been working on it for the past 6 months, and it's just bizarre to finally have it on my head. It's so cool. Yeah, the fit's just amazingly good. It's obviously just built off that 3D scan of my face, so it just really feels like that load's dispersed really well on across the entirety of my face, which is really, really nice. Yeah, I'm really glad I went with carbon fiber inlay parts again, because they're keeping the weight a little bit down. It doesn't quite feel like it's really pulling me forward or anything, which is a good addition. And again, the back tightening system's working surprisingly well. I thought that was going to be a lot bigger problem and take a lot more adjustment than it does, but it all kind of just falls into place on my head. It's really nice. Yeah, and it's cool. The open ear headphones allow me to still kind of hear what's going on outside, which, I don't know, some people might think is a con, but I kind of like being able to know if someone's talking to me in the room. Doesn't block out much ambient noise, but again, I really like having that sort of not total block out disconnect from the world around me. Yeah, the sound quality is also definitely a step above with what it was. The Oculus has a really, really clever sort of speaker system, but it's just not as good as on-ear cans. So it's really cool to have that integrated in the whole design. Yeah, there's definitely no shifting around either. I can like move my head around pretty aggressively, and thing stays locked right on me. So it's really nice. I was worried with the center of gravity shifted forward with the cameras and the sensors that it would make it so the headset wanted to like shift around in my head a lot more, and it's just not happening. It's so great. There's really not a lot of light leakage either. I was a little worried with the transparency of the lattice on the side there would make it so a lot of light spilled in, but it's a little bit, but it's very minor. Probably I'm below what I would get off like the Oculus with just basically the nose gap around the front of the headset. It's just so wild. The 3 USB cables coming off the headset are pretty intense. I'll probably integrate a micro USB hub into that front bezel to get this down to a single cable in the future sometime. Figured I'd rather just enjoy it as is for now and deal with that a little bit later. The multi-USB cables also have a pretty sweet cyberpunk look to them, so I'm fine with it for a little while at least. So now that I have the headset at a place I'm happy with, I want to do some testing on some augmented reality interface mock-ups. The series is really about the physical headset design and build, so I won't go too far into the AR user interface stuff right now. But again, I've come this far, so I thought it'd be fun to do some basic testing. So there's a lot going on with this. My forward-facing cameras are passing stereo video back to my Oculus 2 displays. The digital interface is overlaid on the captured video, so from my point of view, it looks like the digital objects exist in the reality around me. In this version, my digital interface elements can be anchored to 3 specific regions or zones. I can attach digital assets to track parts of my body, like seen here on my left or right arm. For the design style of these elements, I wanted to really push the envelope into complex 3D assets to see how that would read. I think there's going to be an early trend in augmented reality user interfaces to push the existing flat UI styles that are popular on smart devices into the AR space. While flat UI styles work well on screens, I find those conventions translate poorly when applied to dimensional space in AR. Because of that, I explored more complex 3D assets for this test interface. The other thing I'm playing around with is using augmented reality to interact with additional visual systems. In this mock-up, I have a micro-infrared camera mounted to the headset. I can view this camera feed by pulling a virtual lens off my wrist interface there and holding it out in front of me. This allows me to see the infrared spectrum being projected off my phone, which is crazy. Being able to look up at the ceiling and see through the James Webb Deep Space Telescope, or in this case, being able to see and interact with ranges of spectrum that humans can't usually see, is such a radically new and exciting direction to push into with augmented reality. I think that's what really excites me about AR. It has this potential to expand the human sensory field in ways we've never even dreamed of. And with that, this project is wrapped. It's been a pretty amazing adventure taking this idea from start to finish. There were so many unknowns going into this that figuring out how to communicate everything was a real challenge, but I'm so happy with how much I learned going through the process. Hope to come back with some more projects in the future. I've got a pretty long list of concepts and ideas I'd like to explore, so hopefully I get the chance to keep going through them with you. Otherwise, subscribe if you'd like to see more stuff, and thanks for coming along for the ride. Hope to see you next season.